Good to be here. Good to be here at App.js to talk to you about the long tail of type safety. So I'm Simon. I'm a software engineer. I'm a founder. I live in the Bay Area. I've been at a bunch of big tech companies. I've built a lot of things in React Native. And in this particular case, though, I'm going to talk to you more about TypeScript than about React Native. And so a lot of folks use TypeScript, right? Especially React engineers, React Native engineers. And TypeScript is great. We get a lot of confidence in our code. We get worry-free refactoring. We get nice autocomplete in our editor. And ideally, we get fewer runtime exceptions, right? The idea, or the dream, is that we never have to see this again. We never have to see an uncaught exception. Undefined is not a function is kind of a famous one, but really any uncaught exception in our browser console, in our production code. And so the thing is, though, TypeScript is not, out of the box anyway, right, is not type safe. And what I mean by that isn't just that there are some escape hatches, which there are, right? It's not just that you can use things like any and make it not type safe, but even with all of the strictest options turned on, even if you don't use the escape hatches, it's really not a sound type system. It's not fully sound. And I'll use this example to sort of illustrate that. And this looks pretty safe, right? So here we have an array of strings, and we're going to have we're going to create a variable with a type that says, okay, here we have an array that can take string or number, and we're going to assign an array of strings to it. Since string can fit into that array just fine, seems legit, right? But we have to remember that JavaScript is mutable, or arrays are mutable in JavaScript. So as soon as we push something onto that array, we now have a number in our strings array, which is not type safe. And that, of course, could blow up at runtime. And TypeScript won't catch this, right? TypeScript doesn't really have any opinion about this code. It's totally fine. This passes. And you might think to yourself, this is really an edge case that I don't need to care about, right? Like, I mean, who does this sort of stuff? And if you do, maybe you deserve a runtime exception. But no, that's not true. I think the reason I show that example really isn't just because it's some edge case that I think you need to lose sleep over. It's because there's a fundamental design choice that is illustrated by this, right? And it's that TypeScript really intends to be pragmatic over being sound. Like, TypeScript doesn't claim to be sound. It doesn't. It's not a core design decision of the language to be perfectly flawless in terms of type safety. But we're all here to learn about type safety, so we want to maximize type safety. We want to get a little bit more soundness out of TypeScript, at least as much as is reasonable, as much as possible. And why? Well, for all the reasons that we looked at earlier, right? We want that confidence in our code, and of course, most importantly, we want fewer runtime exceptions. So where does TypeScript fall short? Where can we kind of pick things up and get and kind of squeeze more type safety out of the type system? So TypeScript is not null safe out of the box, which is unfortunate, but we can get most of the way there. It is there's a lot of, I call them escape hatches, but there's a lot of ways to kind of do things that you shouldn't be doing, right? Type assertion is a good example, using the word as. And of course, as const is good, but every other type of as is not good, generally speaking. And there's no built-in mechanisms really for validating data that comes from outside of your code, right? Data that TypeScript can't possibly know about because it doesn't exist at compile time. So what can we do about it? Well, I've kind of put it into broadly 4 categories, right? So we can tweak our config, we can get better, we can use lint to try to avoid some of the bad things that we probably shouldn't be doing. We can do some stuff with global types that I'll show you in a minute, and we can do some stuff around the I/O boundaries, which I think is really important. So start with the easy stuff, stricter config. I think the first one here is a no-brainer. Strict is true, and what does that mean? That's a flag that will turn on a whole family of strict mode options, and it's all of these things that I don't think you need to care individually about these, right? You just turn on strict mode, and you get all of these strictness rules, which is great. But the second one on this list here, the no unchecked index access, I think is really important. And so, to put it in someone else's words, no unchecked index access is the most awesome config option that you've never heard of, right? And it's a little unfortunate that like it is very rarely used. It's been around for a few years, but I'll show you an example of what is this strictness rule and maybe why you should turn it on. So most of you could look at this code and be like, well, that's going to fail, right? That's going to blow up in production. And TypeScript is like, nope, that checks out. You told me you have an array of strings. We can call to uppercase on a string. No issue there. And this is kind of the object variant of that, right? It's like, here's a record that has strings in it, so TypeScript will let this fly. And we want to turn on the no unchecked index access, typically just to kind of make sure that stuff like this doesn't creep into our code base. And I'll use a sort of anecdotal example. And so this top line is real code that I saw in a code base, and I'm doing the code review, and I was like, well, why would we use .filter and then use and then get element 0 when we have .find? And it turns out the response was, oh, because .find might return undefined, but the first one will not return undefined. And so that is unfortunately not the case. But TypeScript will allow you to do it, right? TypeScript will let you get away with the first one and say, yep, for sure that's going to be a user coming out of there. So we don't want stuff like this in our code, so we can get the rules a little stricter. Okay, lint rules. Why are we talking about linting at a TypeScript talk? Because TypeScript has escape hatches. And some of the escape hatches are really useful, right? They're things that we want to use, that we need sometimes, right? There's certain times where just like you have to bail out of the type checker. But arguably, you shouldn't reach for them unless you really need it. And so we can use lint rules to help us, prevent us from using some of these escape hatches, right? Using any is kind of the obvious one, right? Everybody kind of knows any is bad. We have unknown, which is the type-safe variant of that. Type assertions, I think folks, especially more junior engineers, don't realize that a type assertion, when you say like X as user, doesn't convert anything to a user, right? It's really just telling the type system, hey, I'm going to override your opinion about this and tell you what this thing should be. Non-null assertion, you might not have heard of this one, and if you haven't, great, because it's a little bit type unsafe and probably good to avoid. And then we have these kind of strange types that you don't see super often, but like function with a capital F. If you type a function as function with a capital F, it'll let you do things that you probably shouldn't be doing. We have better types to do that. So that's where our linting tools come in, and we can it's really easy. We pull in TypeScript ESLint, which I'm sure many of you have in your code base, and you turn on the recommended config, or if you're brave, you turn on the strict preset, and you're off to the races, right? These are the low-hanging fruit, right? This is not crazy, complicated stuff, and then you get the warnings, and it says, don't use any. Now, you can still manually override that. You can disable that if you really need the escape hatch. But I think as a whole, it helps us with our goal, which is to make sure that we have strictness, type safety as a priority in our code base, right? Or the non-null assertion operator, again, like we don't want to be using that. So, okay, better global types. So this is interesting, I think. Typically, you'll see code like this, and TypeScript won't complain because TypeScript doesn't know what came out of JSON.parse, right? It has no idea. And we could try to tell it that, hey, this is an object of a particular shape, but out of the box, JSON.parse will return any. And as we learned, any is really not awesome. And so maybe the takeaway from this is that even if we didn't explicitly write the word any's can creep into our code base pretty easily. And JSON.parse is just kind of, for historical reasons, probably should return unknown, but it returns any, and then TypeScript allows us to do things like this that we shouldn't do. So how do we fix it? We open our global.d.ts file, and we have to paste in some magic code that overrides the built-in type defs for this function, and we say, okay, we don't want any, we want unknown returned, and if we do that, then I don't have the slide for it, but it'll show us an error. Right. So that's a simple one. What about array.isArray? Right. So array.isArray is a nice, helpful sort of type guard that will let us know that, TypeScript can be sure that after this line here that we have an array, but an array of what? Right. TypeScript has no way of knowing what it is, and so it defaults to any. We probably don't want that. We can override that again in the global.d.ts. But like as you can see, the list is going to start to get long. Like how many of these are we going to do, right? And so the answer is the community kind of comes to the rescue and provides, or at least there is this new package that I think is really cool called TS Reset. It kind of fixes a lot of the type unsafe things that are kind of in the built-in type defs, right? Okay. So what happens then? You try to parse something, you call something that doesn't exist, you get an error, and all is good, right? The result is of type unknown. You can't call these methods and properties on unknown. Okay. So now we get to kind of what I think is the more interesting sorts of problems, right? Because like everything so far, it's like, hey, add a config change and drop an npm package of some sort in. But I think here's where things get interesting, right? So our application has I/O boundaries. It has data. It has things that are coming in from the outside world that TypeScript can't possibly know about at compile time, right? And so a typical example of that would be something coming in from the database, but it could be user input, really anything that comes from JSON. We saw a lot of JSON examples. Route params is something that you don't often think about, right? So you might say, use, what is it, use router, use route, and then .params.username and expect it to be there. And so anything that is happening at runtime, TypeScript can't know about it. So what are we going to do about this stuff? So I'll use this example here. And this is from a Node.js backend. I think this is kind of like one of the examples from their website. We try to get some data from request.body. And it's not just that TypeScript doesn't know what request.body is. It's that we can't even know, right? There's no way to know what will be in request.body because it's whatever the user sent us in an HTTP request. So there's like not a great solution to this out of the box. And so you'll see code like this all over, and that of course will break at runtime if you're not careful. But TypeScript won't complain. TypeScript will be totally fine with this. A more kind of React Native example is like async storage. You pull something out of there, you parse it, you expect these fields to exist, and you might have a little more certainty here because presumably we're the ones who put it into the async storage. But again, there's really no guarantees here in place at all. So what is the solution? The solution is validation, which is probably obvious. And there's some great validation libraries. So this is one of the more popular ones. It's kind of TypeScript aware, and I'll show you an example of that. So here. We can just define a schema. We can say, okay, this is what a user looks like. It has this field that's a string. It has this other field that's a string. And then, we use this schema to validate, right? And so this is an example of using safe parse. It has various different methods on it. But here we can say, all right, well, we're not just going to take that data and blindly destructure it. We're going to run it through some validation logic. And what's cool about this is that because it's TypeScript aware, it'll force us here to handle the unhappy path, right? Like we must handle the result.success, or else TypeScript will complain, which is really nice. And once we've handled that case, then we can be certain that it has validated and it's fully type safe. So I think generally speaking, a lot of the problems that kind of fall into this category of kind of I/O boundary stuff can be solved with schema-based validation, right? So essentially, Zod or one of the other similar libraries is the solution to a lot of the kind of untype safe stuff that TypeScript doesn't really give us solutions for out of the box. So the fetch problem, and this is really another kind of extension of the pattern that you're seeing kind of over and over here, but we're going to fetch something from a remote server, and we might be like fairly confident that it's going to send us back some JSON data that has a movies property, and so we'll just go ahead and loop over it and render some movies, right? The issue is that any number of things could go wrong and we don't get back what we expect, and there's no type safety here, right? We wouldn't get any autocomplete. TypeScript wouldn't know what's in this array, what's in this movies array, and so what would we typically do? Well, we'd probably just use a type assertion, right? We'd say as, response body, and we'd write the type for that somewhere and say, okay, well, response body is going to have a property called movies, which has an array, and of course we have to write the type for movie as well. And so this is kind of clunky, and it sucks a little bit, and as we learned earlier, as is not ideal. We'd like to avoid it. So what can we do? Well, if you are lucky enough that your API has open API specification of some sort, then you just run it through a tool, and there's several tools. I'm using this as an example because I've used this in the past, but you generate your TypeScript defs, your TypeScript types, your interfaces, and works really nice if your endpoint, if your server supports that, and then. You still have some boilerplate because you're like, okay, well, I'm going to pull out of my generated schema. I'm going to get the /movies, but I want the response for the get. That's the 200. That's the application JSON, and whatever. It's a little boilerplatey, but at least we didn't have to write all the types and try to like keep them in sync with the server, right? Or we could take it a step further and use a fetch client that kind of understands the generated types, and then you can just say, I'll show a better example here. Then you can just say, okay, well, I'm going to make a post request, and TypeScript is now going to force you to provide the right, fields that the post request is expecting, and similarly with the data that you get back. So, this is an example of where the community comes in and says, okay, well, we can generate types based on some specification. We can even generate a client, an HTTP client, based on that. So, of course, if you're using GraphQL, you don't really have to think about this as much, right? GraphQL libraries are no stranger to type generation, and so if you're using GraphQL, you're probably in a great position with that, right? You don't have to think as much about it. You don't have to care about as much about that. And if you're using tRPC, even better. You don't even have to think about type gen, right? tRPC is this really cool type-safe way of just calling functions on your server. Now, so yeah, if you can use tRPC, absolutely go for it. The downside is you need to be running TypeScript on the server. You kind of need this mono repo set up. Like there's requirements that need to be in place. But okay, what is tRPC? Move fast and break nothing, end-to-end type-safe APIs. I think it's really useful. I think a lot of folks in the community have kind of rallied around building type-safe tooling like this, and that's great. Okay, so we only have a few minutes left, and I want to talk about routing and navigation. Okay, so everyone probably uses React Navigation, right? That's the thing to use. It's a good library. It does so much, right? It handles everything from gestures and animations and like really complex navigation setups, and it's fantastic, right? Typically, you'd write some code that looks like this. You'd have you have some nice hooks you can pull in here. The downside is if you write code like this, in your editor, you're going to see stuff like this, right? You're going to see some red squigglies, and that's your editor trying to be helpful, or TypeScript trying to be helpful and say, well, I don't know if there's a username prop on this thing. We have no way of knowing that at compile time, right? We have no idea if there is a page called home that you can actually navigate to, and or worse, you're going to see an error like this, which you're like, I don't even know what to do with that, right? So what do? Well, we go to the docs and we're like, what is the official way to add types? And you end up writing code like this, right? So you've got like root stack param list, and you've got all these kind of like utility types to essentially describe the, so you end up having to describe the navigation twice, right? Kind of one in the type system and then like another time in the, kind of JSX, right? So anyway, it works. This is the norm. This is the status quo. This is kind of what we do to make it all work. And what you end up probably with, so this is the, this is the solution to what we saw earlier, is that you have to add the angle brackets. This is just us telling TypeScript, hey, I'm really certain that because we're in the user profile component, this is going to be a user profile route prop, right? But that's essentially not much different than using a type assertion, right? And as we learned, whenever we're overriding the type system and saying, hey, look, I'm just going to promise you, I guarantee you it's of this type, right? That's, that's risky. And also, you're going to end up with like tons of code like this, right? So this is code that would probably sit somewhere in like a, in a types folder, and you'd have to describe all of your routes and everything. So anyway, it works. It's a little bit of boilerplate, but we get fairly decent type safety out of that. However, as many of you saw yesterday, we now have a better solution, right? So Expo Router has been around, but Expo Router v2 has, it actually has, like, it's type aware, right? It has type safety. And so, the reason I bring this up is not to say, okay, that was too much boilerplate, like rip out React Navigation and like immediately change technologies. That's not the right solution to everything. But I think this illustrates what's happening, which is that the community is kind of rallying behind good type safety and end-to-end type safety, and making sure that we can, not have to write the kind of code that you saw in this slide, which, like, this doesn't make TypeScript fun, right? Like, none of us want to do this sort of thing. So anyway, I thought this was really cool. The community in all areas, but in this particular case, I think this is a great example of where type safety is becoming a priority. So the code we ship should be more type safe. Maybe this goes without saying, but the long tail of type safety is like handling all those edge cases, handling all the things that kind of TypeScript doesn't give us out of the box. And some of those things are simple, like adding a line to your tsconfig, or generating some types using some package off of npm. But I think there's a lot of opportunity, especially around the I/O boundaries. So that's my talk. This is me. The slides are at this QR code, and I really appreciate y'all sticking around talking about type safety with me. Thank you.